invite up Dr. Luke Barnes, who will be speaking for the affirmative. So Dr. Luke Barnes is an astrophysicist and cosmologist at Western Sydney University. He completed his undergraduate studies at the University of Sydney before undertaking PhD research at the University of Cambridge. He is the author, together with Geraint Lewis, of the book A Fortunate Universe, Life in a Finely Tuned Cosmos, which was published by Cambridge University Press. So please welcome up Dr. Luke Barnes.
All right, thanks for coming out. Start my timer so I don't go over time. Good. I like debates because they make you listen to a perspective that's not your own, and interesting things can happen if we sort of shut up and stop interrupting each other and let someone talk for 15 minutes. For example, Peter has a video on YouTube that you should go and find called Is Western Civilization Doomed? And I'm not going to give away the ending, but you should go and see what he has to say about that for 15 minutes. Let me get straight to the point here. There's my opening slide. So my contention here is that physics has kind of stumbled across a way of testing an idea called naturalism. Naturalism, as it's defined by people who call themselves naturalists, is the idea that there is only one realm of existence, the natural world, whose behaviour can be studied through reason and empirical investigation. So the short idea here is naturalism is the idea that natural stuff is the only stuff. There's no other type of stuff. I want to rely here on what I'll call a principle of reasoning, and I'll give an illustration rather than get into technical detail. So here's the illustration. So suppose a safe has been robbed, and when you look at the security footage, when the detectives look at the security footage, they see that the thieves have put the security code in on the first attempt. They just walked up, put in the code, and took the money. Now, how would we consider why that happened? Well, there's two sort of theories. We could say A, it was an inside job, or B, maybe they just guessed the code. Now, when you're a scientist, you're using probability theories, one of the crucial things that you would want to ask, a crucial question to ask of any theory, is this: what would we expect to be the case if the theory was true? If you like probabilities, this is known as the likelihood. If you don't like probabilities, forget I said that. So, on theory A, what would we expect to be the case if it was an inside job, if the robbers went up knowing the code? Well, we'd expect what actually happened in the security footage. We'd expect them to walk up and simply open the safe on the first attempt. What we expect was what actually happened. All right, now let's think through theory B. What if the thieves walked up and just guessed the code? Well, we need a crucial extra bit of information here. We need to know how many digits the code has. If there are 3 digits, right, then there are 1,000 possible codes from 000 to 999, and so the probability of guessing the correct one is roughly 1 in 1,000. If it's a 12-digit code, because there are so many more possibilities, and because on this hypothesis they're totally at the mercy of all those possibilities, they have no more information, the probability of them guessing correctly is now 1 in a trillion. The guessed theory, they just guessed theory, leaves the thieves at the mercy of a large set of possibilities without any help. The thieves could have guessed any code, and the vast majority of codes don't work. We would expect, with overwhelming probability, that the thieves would punch in the wrong numbers. So this is why the theory is in trouble. On the theory, what you would expect to be the case is not what was actually the case. But a small probability isn't enough. That's an important point. Right? Small probabilities in and of themselves don't mean that much. We need a better theory, and in this case it's the inside job theory, which is not at the mercy of a huge set of possibilities. On that theory, what we would expect is what is actually the case. That's my illustration. The general point is this. We have to ask the question, what would we expect to have been the case if the theory were true? This is how we test ideas. And the key to that is knowing what is possible, what possibilities are consistent with what is actually the case, and whether there is any reason to expect any particular possibility. That's our principle, explore the possibilities. With that done, let's have a think about science. Every scientific theory, every fundamental scientific theory has basically the same structure. This is sort of a remarkable fact. You say you have a list of things, the stuff that the universe is fundamentally, I'll get there, that the universe is fundamentally made of. You have 2, an equation which says how that stuff behaves, and then 3, you need what are called initial conditions about how the stuff started off. This is true for Newtonian mechanics, just to be a bit of a physics nerd here for a second. Alright, the stuff is particles, the equation of the laws of Newtonian mechanics, of course, and the initial conditions are the position and velocity of every particle. It's true of quantum mechanics, you can talk about wave functions and the Schrodinger equation. It's true of general relativity, it's true of all of them. If you are a naturalist, if natural stuff is the only stuff, then there is some set of these 3 principles which defines the ultimate principles of reality itself. At some future meeting of the really important physicists, Einstein's great-great-great-granddaughter Alberta could walk up slowly to the blackboard, dramatic music, scribble a few equations, and fundamental physics would be over. Right? So if you're a physicist, a horrifying thing to think. We would all be out of a job. You can ask deeper questions if you like, but no answers will come. It would be like if some chess pieces actually worked out what the rules of chess were. As far as their own little universe there, fundamental physics would be over. And the important thing is, if you're a naturalist, a set of laws like this will define the deepest principles of all reality. No deeper principles of reality exist at all. That's the game. So what we now want to ask, right, following our principle, what would we expect to be the case if naturalism were true? And the principle invited us to explore the possibilities. So, if these are the fundamental principles, what could the universe have been like? The relevant set of possibilities here is every mathematically consistent set of laws. Remember, there is no deeper principle than those ultimate laws. So if you write some mathematically consistent set of laws on a board, there's no other principle that can say, this can't be reality. There's nothing to rule it out a priori. This is why we actually have to go and look at the universe. So remember that as the set of possibilities got larger, from 3 digits to 12, things got worse for the they just guessed theory. The more possibilities, the more trouble your theory is in if you're at the mercy of those possibilities. For naturalism, this set of possibilities is literally all of mathematics. Right? I'm a theorist. I have entire pens full of equations that I could write on a board. And if you're a naturalist, only one set of mathematical laws is the actual laws of the universe. And so we could say, we could stick Alberta's board in the middle, surrounded with a whole heap of other blackboards, and fill all of those with equations till our heart's content. Have you ever seen a mathematical library? Some of you look like you don't want to see a mathematical library. That I understand completely. Okay? You could stare at the ultimate laws of nature for as long as you like, but no answer will come as to the fundamental questions that you might ask about that. Why does reality obey that law rather than another? Why is there stuff that obeys laws at all? Why is stuff that makes stars and planets and people? But no mathematical equation predicts its own success. No mathematical equation can demand that reality obeys me. Here then is the naturalist predicament. We must explore the possibilities. What would we expect if naturalism were true? Well, the set of possibilities in question is the complete set of all mathematically consistent laws. The English language is not equipped to convey the impossibly infinite enormity of that set. And here's the kicker: on naturalism, there can be no reason to expect any one rather than any other, because there are no deeper principles than whatever ends up on Alberta's board in the middle there. That board will have nothing to say about all the other boards. This idea, naturalism, is then at the mercy of every possible way that physical reality could be. And if we're thinking in terms of the larger the set of possibilities that you're at the mercy of, the worse your idea is. Naturalism is quite literally the worst idea ever. It is the worst idea imaginable. Here is where fine-tuning comes in. we can make this idea, perhaps unexpectedly, quite precise. You might throw your hands up and think, well, we can't think through all the mathematical possibilities. That's a bit ridiculous. But if you're a physicist, we come across these problems all the time. If you're faced with some infinite set of possible theories or observations or whatever, you boil it down to a smaller problem that A, you can handle, and B, seems to represent the larger problem. Here is what I suggest is a useful smaller problem. We'll take some pieces of these laws, of the best laws we have, and look systematically through those. Specifically, we will look at the constants of nature, things like how much does an electron weigh, which appear in point 2 there in the equation. Secondly, we could vary the initial conditions of the universe, number 3 there. This is literally the set of scenarios that are physically possible given a certain law. This smaller problem has a lot to recommend itself to us. It stays very close to our best physical theories of the universe. We can even borrow the probabilities that we need to use in theoretical physics to test physical ideas. These probabilities are a measure of our state of knowledge, not a statement about any chanciness in reality. These are Bayesian probabilities, not frequentist probabilities. This, I contend, is a reasonable way to investigate naturalism. Physicists calculated all the relevant bits and pieces over the last 40 years for other reasons. They weren't trying to test naturalism, we were just trying to test our theories. And what we have discovered overwhelmingly is that the necessary conditions for life are extremely rare amongst this set of possible universes. Theists did not invent this. It is the discovery of a whole host of scientific papers. Right? The reason why Victor Stenger wrote a book is because he never wrote a paper about it. I wrote a review of his book, which cited over 200 papers from the scientific literature and was published in publications of the Astronomical Society of Australia. His book sunk into oblivion. That is not the consensus of the scientific community. There is, at the moment, a project going on at the University of Oxford in their astrophysical department called the Consolidation of Fine-Tuning, which is about to publish a book summarising the entire literature. Okay? We had our conference last year, it was in Crete, it was lovely, and all sorts of eminent scientists were there, and the idea that the universe was fine-tuned was not really discussed by anyone. Okay? Not really questioned. Okay? I wrote the book A Fortunate Universe with my colleague Geraint Lewis. He's an atheist. We wrote the first 7 chapters together. The bit we disagreed about was what on earth this fine-tuning means. Let me look at some examples, because this is fun. These are some simulations we've done of the universe. You stick a whole universe in a computer and teach it to interact with itself via gravity and all sorts of fun stuff. If you have 0 cosmological constant, then the one on the left, it makes structure in the universe like ours. I'll run it again because it's great. So this is the... I'm bad enough, aren't I? This is the way structure forms in our universe. Gravity makes dense bits of the universe even denser and galaxies form at the centre there. As you increase the value of the cosmological constant, let me write it again, the expansion of the universe kicks in very early and everything moves away from everything else in the universe, and the expansion of the universe stops structure from forming. If you look at the entire range that the cosmological constant could have had in our theories, the range which allows any structure whatsoever to form in the universe is about 1 part in 10 to the power of 90. Similarly, we can look at fundamental particles. Over the range in which of masses that fundamental particles could have, the range that allows any structure whatsoever is about 1 part in 10 to the 17. But of course we need a better theory. Now, one of the problems here is that for some people the word God evokes pictures of a beardy man in the clouds. Just a bit of advice for any atheists in the audience. If you're talking to a theist and you start referring to God as a sky fairy, this will have the same effect on us that telling a Star Wars telling a Star Wars fan that your favourite character is Jar Jar Binks. We just internally up here, without saying anything, we just set your credibility to 0. We have not tried to understand the idea of God. It's worth noting you can't be an atheist if you don't know what the word God means. So, if we think about God, the important thing not to do, sorry, too many words there on the slide, the important thing not to do is take a naturalistic universe and try to just staple God onto the top. We're familiar with matter, which obeys causes, and minds, which are actual reasons, and the idea of theism is that fundamental reality is more like a mind than like matter. if we are trying to understand the universe in these terms, can we think of a reason why the universe would be the way it is? And I think we can. This universe creates and sustains moral creatures in a morally significant environment. Our universe, we have real freedom. Our universe is neither morally hopeless, nothing we do matters, nor is it morally trivial, it's all sunshine, lollipops and rainbows. If you want good things to happen in this universe, you've got to pull your socks up and get to it. We are not playing with Monopoly money. So this is a morally valuable universe, and it's that connection between the moral value of this universe and the goodness of God that means that we have a reason on theism for there to be a universe like this one. And I will finish 5 seconds early. Thank you. I'm going to go down here.
Can I grab the clicker from you?
Yeah, sure. Why not?
Alright, thank you very much, Luke. So I'll now invite up Dr. Peter Slezak, who is an Associate Professor of Philosophy at the University of New South Wales, and he specialises in philosophy of language, psychology and the work of Descartes. Peter did his PhD in philosophy at Columbia, New York, and I'm very grateful that he's here as he arrived back from Jerusalem only last night. So I'll invite him up to speak with us now.
Thanks, Rebecca, and thanks everyone for coming along. Look, I prepared my talk before I heard what was said, and as the last speaker, I can't resist saying a few things by way of refutation or response to the other speakers. So let me do that really quickly before I get into my slides. Look, let me just start off with really giving you a kind of a way to approach this. It's wonderful that there's all this science thrown at you, but it's all bluff and a kind of a snow job. And the reason I say this is a couple of things. Firstly, we had Mike talk a lot about wonderful science, and his arguments really were about the beginning of the universe and that there had to be a cause. Now, the debate isn't about that. It's about the design of the universe, and strictly speaking, they're separate arguments. There's a lot of literature and an immensely interesting debate about what happened when there was nothing and then there was something. But the question about design is completely separate. And even if God made the Big Bang, the question of what it looks like and whether the order in the universe leads us to the idea of a designer has to be kept separate. But on the Big Bang cause thing, one thing that has to be said is that the theorists who talk about this, they basically cheat, and they're not fair to you. It's unfair to go into all of this physics because actually within the science and within the arguments about causes, the notion of a cause can't be used to explain the singularity, because the notion of a cause, as many theorists have said, in response to other theologians and believers, the notion of a cause is something we only understand after the Big Bang in terms of what are called Humean causes, and the singularity is when time and space began, and so the notion of cause doesn't mean anything. And the reason that you have to understand that they cheat when they do this, and I'm thinking of some of the great theologians here, I can mention by name William Lane Craig is one who's very eminent. When you press them on the point, how could God or something have caused the Big Bang? He says, well, look, I don't mean cause like science, I mean a metaphysical cause. You ought to ask, what do you mean metaphysical cause? Because they just made that up. That's not part of science, and they know it. So causes of the Big Bang are not a legitimate part of the argument, and they're just inventing that as something that they... I mean, I can make up any story I like. It's equally responsible to science. In other words, it's not responsible to science. So there's other thing I want to say about that. Luke referred to naturalism as though this is somehow an unfortunate philosophical approach. It's like, you know, kind of a boogeyman. Naturalism, I've got a simple formula to explain how you should think about science and what philosophical or metaphysical position you should adopt. It's a very simple slogan. In fact, I've got a very simple formula when it goes to Big Bang as well, which applies to naturalism. My view as an atheist is whatever is in the best textbooks is what I believe. Anything else you're just inventing. And what's in the best science textbooks constitutes naturalism. In other words, the only sensible view of naturalism is whatever our best theories say. And the only alternative to our best theories in physics or chemistry or biology is worse theories. So what have you got to offer in biology or chemistry or anything else other than what are our best theories? And my simple approach to this is to just believe what our best theories say. They don't give you any grounds of the sort that are being suggested here, because otherwise they'd be in the textbooks. So that's my prefatory remarks. Let me get on to my slides, and I'm going to have too many probably. Look, I was going to start, and I'll probably run out of time pretty quickly, but I wanted to start with some cute ways in which children can think about this question more clearly when they're not snowed by all of this stuff. And kids were asked to write letters to God, and they're very revealing. One of the kids says, "Dear God," if it's in the Bible, it's true, isn't it, like in the Encyclopedia or Wikipedia. He's trying to make sense of how to believe these things. And one of the kids says, "I read your book and I like it. Where do you get your ideas from?" Well, that's a fair question. There's another one about the Big Bang cosmological argument. The kids told the story and they find it hard to believe. And he says, "Dear God, if you made the sun and the moon and the stars, you must have had a lot of equipment." Well, these are very sensible questions. This is before they learn to internalise the official story. And this is the argument from design, which is supposed to be the theme for today. A kid asks God, "Dear God, did you mean for the giraffe to look like that, or was it an accident?" Well, these are kind of cute because the kid can't quite fit the story together. Well, now look, I'm going to slip through the slides pretty quickly, but some things are design. These are all the things we know. And by the way, I'm going to say, to let you know in advance, the argument I'm going to give you is not new. It was actually put forward by David Hume famously, the 18th century Scottish philosopher, who had a collection of dialogues called the Dialogues on Natural Religion. And he answered the argument from design in its classical form, and it still is the appropriate answer to contemporary versions of it. Now, some things are designed by human beings. Other things are not. They kind of look similar, but we know the story that goes with this. And there's a psychological problem here which goes back to the issues of probability and so on. Psychologists give people blots and ask them what it looks like. Well, you can do this as they do in psychology, to see a bunch of dots. Sometimes there's something there, if you can see it. There's a dog in this picture. Sometimes they're not. But it often depends on your prior prejudices or biases. And I've just done this for fun, but I haven't got a lot of time to go through it. This was actually in the philosophy of science textbook. And for many years I couldn't see anything. Who can see something in this picture? Who cannot see anything in this picture? I looked at it for years until I could see. They said there was a face in the picture. It depends on your prior theory. Well, I played with it and say, well, if you see it that way, you can start to see a face in it, and perhaps it's appropriate in this context. But it depends on your theory. I looked at it for years, and when I saw something, I saw something else. Well, in fact, I think the original is just a snow field on a mountain. And the question is whether there's any pattern there. And we're very prone to reading into patterns where there isn't anything. So there's a whole literature. Another example, this is actually the stock market, and you might ask, is it random? Well, people have paid a lot of money to tell you that there's a pattern here, and then you invest your money and you lose it all because this is the digits of pi added up, reversing signs, and it's got exactly the same shape. Well, one's random, one's not. So, don't believe the chartists when they tell you to invest your money in the stock market. Now, look, the classical argument from design came in the form of an essay by William Paley, where I won't go through it very in detail, but it was also put forward in a similar version by David Hume, who answered it very well. But Paley's idea, roughly, was this. If you're walking across a field somewhere, you bump into a stone and you pick it up, well, it's not interesting because the stone doesn't have any design. But let's say you bump into a piece of clockwork and you don't know where it came from, you look at it. And he said, it's obvious that this has a function and it has a design and an intelligence behind it. And his point was, which is really at the heart of this discussion, the whole universe is clearly, beautifully designed to fit together. All of biology, although today we were talking about the fine-tuning, and it's the same argument because the cosmology and the constants of physics, if they weren't all exactly as they are, the world wouldn't work. The whole universe would fall to pieces, and that's what we've heard from the physicists. The question is, what follows from that? And the answer is nothing. And the reason is what Hume actually gave. I was going to say that life on Earth isn't designed, and biology now tells you that we're some remote little piece at the end of this tree of life. We're an irrelevant little accident, and the statistics show that bacteria are the point of everything because there's more of them, and we're at the tail end of the statistical distribution, and like any distribution, it's kind of an accident. And so if you're looking for design in the universe, bacteria are are God's kind of ideal for what the world should be like. And the other thing about design in biology, without going back into the physics for a minute, because the biology is kind of one of the main areas where people see intelligent design, you have to look at the way things are designed, allegedly. Why would a bird and a bat and a crocodile and a mouse and a dog and a seal and a whale all have 5 fingers? It's really a kind of an odd design. Here's a porpoise or a whale. Why does a whale have 5 fingers in a fleshy flipper? If I was God, I'd give it a propeller. I mean, if you're talking about design, it's much more efficient than 5 fingers in a fleshy. Obviously, it's a joke, but it's not seriously. you can't take seriously the idea that these things are designed. Evolution tells us they're all developments from an initial accident. Now, of course, the Big Bang, I happen to have here a slide about the Big Bang, and of course there's this wonderful physics about it. But leave aside the cause of the Big Bang, which I've mentioned, the idea that there is a design here is also equally unwarranted. And the argument is often made, look, it's like, if you had a tornado go through a junkyard, the idea that it would create a Boeing 747 by accident is so improbable. Well, it seems that way, but here's the alternative. If you understand probabilities, it depends not only on the absolute probability. Our judgment is like those random dots. The judgment depends on our interest. If you ask somebody, what's the chances of getting a perfect bridge hand? I don't play bridge, but if you've got 14 spades, it's some number, huge number, 635,000 million to 1. So you ask yourself, what's the chances of any stupid random hand that you get usually dealt in the bridge? It's exactly the same. Now, if you've got all of the spades, you call up the newspaper and tell them that this is like a 1 chance in a gazillion. Every boring hand has the same probability, but you have an interest in one. And so you rank it more highly. Someone has to win the lottery. The chances against winning the lottery are huge depending on the number of tickets. So you can't judge exactly what's going on. Now, I'm running out of time quickly, so I want to just hint at Hume's arguments. Hume's made some very powerful arguments against the idea of design. Firstly, like those chairs that I had up there, those are designed. The idea, he said, at best, the argument is a kind of analogy. You're taking things that we know are designed and applying it to the entire universe. This is a really bad argument. To take things that we know and apply this as the principle of the whole universe, where I had quotes from him I won't be able to go through, but he said, look, there are lots of other kinds of causes besides intelligence. Intelligence we only know in human and animal brains. And he has a lovely remark about why would we exaggerate the importance of this little agitation that we know in our brains. He says this is an arrogance, that we're assuming that our little brains and the little causes that go on in humans and other animals is the cause of the entire cosmos. This is a kind of anthropomorphism. And I think I've got to, well, let me just mention the other arguments. Firstly, the idea that it's perfect is also a mistake by comparison with what? This is David Hume in the 18th century. He says maybe this is, he was being very cheeky, he says maybe this is the product of a god who was an infant god and he was playing with Play-Doh and just made a mess of it like kids do. Or maybe it was he called it a superannuated deity who was senile and he just messed it all up. What's the comparison? This is Hume's argument. In any case, it doesn't lead to monotheism because maybe there's a whole committee up there. This is his argument, it's not mine. Now, whoops, what have I done? Oh, I've lost the, how do I go back to the slides? Oh, thank you. Let me just read it because it's so nice. He says, why select so minute, so weak, so bounded a principle as the reason and design of animals is found in this universe, and why exaggerated sound philosophy should guard against so natural illusion? Let me go on to quote. Now, that's what's called anthropomorphism. Every time we think of extraterrestrials, which includes God, we can't help thinking of it as a human being. As you know from Christianity, we give him human attributes because we can't think easily of any other kind of extraterrestrial. Here's a quick question. These things look like they're designed. We know what they are. They're snowflakes. Are they designed? Well, of course not. We know that there's a principle behind it. The universe is just the same, the fine-tuning. There's a theory that goes with it. I did a bunch of graphs when I was a student as an undergraduate, designing what are beautiful designs, but in fact, they're simple harmonic motion in two different directions, and the physicists will understand this, exponentially decaying. And there's my calculations when I was an undergraduate student. This isn't a design, it's the way nature works. You can create a pendulum diagram like that. Now, let me just end. I'm winding up a little bit. Einstein had the key to this. Now, for all the physicists that our friends here are telling us, I had a review of Paul Davies' book years ago called The Mind of God, where Paul Davies is a great physics writer and a good physicist. He tried to run the same argument, that the fine-tuning couldn't be an accident. Well, he gives a really awful argument, and he cheats the way that I've suggested cheating. You can't read an intelligence into it, and Einstein gives the answer. Einstein, who was, I think, understood physics at least as well as Paul Davies does, has the following remark. Let me read it. Science purifies the religious impulse of the dross, he said, his words, of its anthropomorphism, the idea that we read human attributes into everything. He says, the more a man is imbued with the ordered regularity of all events, the firmer becomes his conviction that there's no room left by the side of this ordered regularity for causes of a different nature. For him, neither the rule of the human nor the rule of the divine will exist as an independent cause of natural events. There is no other grounds for believing. Naturalism is the only theory or metaphysics that's available to us. There just isn't anything else, and therefore you have to rest content with what science tells you. I finished earlier than I thought with my slides, but let me just say one or two other things that was mentioned to persuade you. Let me summarise, since I have a couple of minutes or a minute left. The Big Bang argument doesn't justify anything causing the universe, because that's a notion of cause that there's no warrant for in science. You can read the literature on this and it will show you that people who argue this have no basis for the argument except making up metaphysics and using words that are really kind of scare words to impress you to think, oh my goodness, metaphysics, that must be deep. It's an invention, and they use that word. The second thing is that the argument design is an awful argument for the reasons David Hume pointed out. And finally, it was only mentioned in passing, the universe must have a moral value. This is a whole seminar's worth of discussion, but morals are something, and values are something that human beings have because we have to live our life in a certain way, and you can't use our needs for a moral and an ordered life, which is to some extent based in our biology. You can't use that for a proof that there's anything out there, because if there weren't human beings and there was no sentient life, there'd just be a bunch of planets and atoms and hadrons and quarks and whatever else is going on just bouncing around in the universe. That's what our best science tells us, and that's all we should have any grounds to believe if we are modest and intellectually honest about what we have grounds for believing. Thank you very much.
Thank you very much, Peter, and thank you to all of our speakers for sticking to time so well. I was thinking I need to ring the bell multiple times there. So as you can see on the slide, we're just going to take a very quick break, just for a couple of minutes. So if you want to stretch your legs, clear your brain, grab some water at the back, and we're going to pick up again in just a